Awesome. Okay, let's take everything we learned about our first and second derivative test and put it into practice. Here's our very first problem. We're going to look at 4.18. We are going to graph f of x is equal to 3x minus x cubed. Now remember, with our first derivative test, yes, we can find minimums and maximums, but we also talk about increasing and decreasing. That is important. So it's a big deal to learn where my graph is increasing and decreasing, not just my max and min. All of that plays an impact. So the first thing we're going to do is a first derivative test. Guess what? We have to take a first derivative. So let's do it right now. It's pretty sweet with a polynomial. So we've got f prime of x is going to be 3 minus a 3x squared. Now, keep in mind, when we go through and we're taking our first derivative, we want to find critical values. And in order to find critical values, we need to factor. So I'm going to factor out a 3, and I have 1 minus x squared. Then let's factor that down. I've got 1 plus x and 1 minus x. So if we set this equal to 0, then that's going to give us our critical, I'm going to scoot this up just a little bit. That's going to give us our critical values here of 1 and negative 1. All right? So now those are the values I'm going to use to build my chart. So we've got our first derivative. We're going to build our first derivative chart. So we have an interval. We're going to determine if my first derivative is either positive or negative, and then that's going to tell us increasing or decreasing. So we've got negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Now remember, when you're filling out these charts, all you're concerned about here is if it's positive or negative. So we want to try to find something that's easy to work with. Well, if I'm looking at this, f prime of negative 2 will fit that bill. So I'm going to take negative 2 and plug it in. If I'm plugging it in here, I know that I'm going to have negative 2 times positive 1 is a negative. And positive 1 and negative 2, remember, this is negative 2, so you add the opposite, so that's going to be positive. So a negative times a positive is, I'm going to scoot this over a little, a negative, right? Negative times a positive is a negative, and so I know that this is decreasing. Do you see what happened there? I'm plugging in a negative 2. 1 minus 2 is a negative. I plug a negative 2 in here, and minus a negative is add the opposite, making that positive. So a negative and a positive, that's where my negative comes from. That's all I'm concerned about. I don't care about that actual value, just that it's a negative. Okay, now let's plug in 0. That makes that positive, and that's also positive. So that's positive, giving me increasing. Let's try 2. If I take a 2 and plug it in, that's going to be positive. But a 2 there, 1 minus 2 is going to be negative. So a positive times a negative is a negative again, and then my graph is decreasing. This is important. This tells you how your graph is moving, and that's a big deal. Once I figure out how my graph is moving, I know that this is decreasing to increasing. That's going to be a minimum. This is increasing to decreasing, and that's going to be a maximum. So I actually have here a minimum at, at x is equal to a negative 1, and a maximum at x is equal to positive 1. So remember, I'm going to squeeze this in. When you find your points, your critical values come from the test. Your points come from your original function. So you plug that in. F of negative 1. I'm plugging it into my original function. 3 times negative 1 minus negative 1 cubed. So negative 3 minus a negative 1. So f of negative 1 is a negative 2. There is my minimum. -1 and -2 on my graph is that point right there. Now I look at what is my maximum. F of 1 is 3 times 1 minus 1 cubed. So 3 minus 1, f of 1 is 2, and that is my maximum at the point 1, 2. So now I know that I have a minimum, which means that my graph's not going to go any lower at that spot. And a maximum, which means my graph's not going to go any higher at that spot. Where I see all the time people making errors is they try to draw through those. Graph what it is. Graph what it is. If it's a maximum, if it's a minimum, you know that it is, and this is a polynomial, so everything is a smooth, continuous curve. You've got it. Okay, now there's our first derivative test. Well, we're not finished yet. We have to figure out concavity. And we can figure out concavity with a second derivative test. Now, here's the deal. We have to take a second derivative. I'm going to squeeze this back down here. Am I going to go about this trying to take a second derivative from something that's factored out? No. I'm going to come back up here to this level right here. 3 minus 3x squared. And I'm going to take a second derivative based on that, right? So if my first derivative is 3 minus 3x squared, that's a 3. My second derivative is going to be a negative 6x. And whenever I figure out my critical value, x will equal 0. And then we do the same thing. You have an interval. I want to know where my second derivative is either positive or negative because that tells me concave up or down. That's an arrow. So I just have the critical value of 0, so I'm going negative infinity to 0 and 0 to infinity. Again, we're looking at plugging my second derivative into, or some value into my second derivative. So pick nice things. Something that is easy for you. If I plug a -1 in here, a negative times a negative, that's a positive. So I'm concave up. If I plug a positive 1 in here, 1, so negative times a positive is a negative. That's concave down. When you change concavity, what do you get? Yes, an inflection point. So I'm changing, if I change concavity, that's where you get your inflection point. And I'm going to get an inflection point at x equals 0. So where do I get points? Into my actual function. So let's try this. F of 0, let's squeeze this back down here so we can actually see our original function way up here. So 3 times 0 minus 0 cubed. And that's obviously 0. So 0, 0 is my inflection point. So I'm going to graph 0, 0 right here. Now we are going to use, that's why all this part is so important, increasing, decreasing, and concavity. I know my graph is going to decrease, right? So it's going down through here. Then I hit my minimum. Then I increase, I hit my maximum, and I decrease again, right? Also, in that, I know this part has to be concave up. Then at this middle, right here at this 0, I'm going from concave up and I switch over to concave down. Do you see that? Okay, now this one's kind of a wimpy little problem, if you will, because I know that this is going right there. I don't need tons of points. We have our points. We have our increasing, decreasing. We have our maximums and minimums. We have everything we need in order to graph this function. Just graph it at that point. All right? Cool. There's a polynomial.